When my thoughts wander, and they often do, and I think about artillery, this is the gun I think about, the British 25-pounder. I see lean, bronzed artillerymen stripped to the waist, mouths dry, nerves shredded. I wonder, will they actually survive yet another last stand, pouring shot over open sights into the latest German armoured thrust? The 25-pounder with a calibre of 3.45 inches or 87.6mm was a field piece of field artillery used by the British and Commonwealth forces in the Second World War. Durable, easy to operate and versatile, it was the most produced and used British field gun and gun-howitzer during the war. It was introduced into service just before the war started and combined both high angle and direct fire abilities. It had a relatively high rate of fire and a reasonably lethal shell, and it was a highly mobile piece. Initial production was slow, but by 1945 over 12,000 had been manufactured. It remained the British Army's primary artillery piece well into the 1960s, with smaller numbers used in training units until the 1980s. Many Commonwealth countries used theirs in active or reserve service until about the 1970s, and ammunition for the weapon is currently 2020 being produced by the Pakistani ordnance factories. Whilst researching the 25-pounder, I found this old wartime documentary describing 25-pounder in detail. I hope you find it interesting. I certainly did.
The 25-pounder is the new field artillery gun. Here it is limbered up to its towing vehicle, which is known as a quad. The gun is now being unlimbered. The 25-pounder replaces the 18-pounder and the 4.5-inch howitzer. It fires a shell weighing 25 pounds for a maximum range of 13,400 yards with supercharged shells. Let's take a look at each part of the gun. Here is the basic structure. It consists of a trail, axletree, and wheels. The carriage rests on 3 points in action. A spade is fitted to the rear end of the trail. To prevent back movement on firing, just above the stage is the trail, which is for attaching the carriage to the trailer. At the front end of the trail is the axle, and at either end are wheels with low-pressure pneumatic tires. The gun can be fired even if there is a flat tire. At the side here, there's a lever which works the brakes. These are the internally extending type. Underneath the trail and at the side, there are brackets for attaching the firing platform. The spade is now masked by the spade box, which prevents the spade sinking into the ground. When the platform is being used, the gun can, of course, be fired without the platform, in which case the spade is left unmasked. Let's deal with the superstructure. The first part is the saddle, which supports the cradle and gun. On top of the trail, there are 2 fossil bronze bearing strips on which the saddle rests. At the front there is a bearing for its pivot, and there are 2 guides, which are engaged by clips on the saddle. These hold the saddle down at the rear end. Here it is, in position. Its main job is to allow the gun and cradle to be traversed. On top of the trail, this is done by the traversing gear, which gives a movement of 4 degrees. On either side of the central line, the next part of the superstructure is the cradle, which holds the gun and recoil mechanism. It's now in position. The purpose of the cradle is to give elevation to the gun and guide the recoiling parts. At the rear end, there's an elevating arc. This engages with the pinion of the elevating gear, which is fixed to the saddle. The cradle is now being elevated. The maximum elevation is 40 degrees. Now it's being depressed, with maximum depression of 5 degrees. To prevent strain on the elevating gear, when the gun is traveling, the cradle is secured to the trail by the cradle clamp. Here it is in position. For firing, the clamp is loaded back against the left side of the trail, where it's held by its caps. The next component is the recoil system. Here it is in the cradle. On the left side of the saddle, here goes the sighting system. It's used when laying the gun for line and elevation. We'll tell you more about the recoil system and sights later. On top of the recoil system are 2 projections. These carry the piece, which is the name given to the part of the gun, which actually fires the shell. There are 2 tubes, a loose barrel, and a jacket. The loose barrel can be easily removed from the jacket, so that when it's worn out, it can be replaced by a new one, which should be performed every 3 months. Let's see how this is done in detail. The gun is laid horizontal, and as we're going to alter the position of the center of gravity, the elevating hand wheel is lashed. This will prevent the gun elevating of its own accord. The brakes are put on to prevent any movement of the carriage. The breech mechanism is now dismantled. The breech ring must be unscrewed. This is not possible unless the breech block and other parts of the breech mechanism are dismantled. The securing screw of the breech ring having been unscrewed, the breech ring is removed. The breech ring is attached to the jacket by interrupted threads. There is a hole for the securing screw. The sealing collar is now unscrewed. The 2 Ferrado packing rings inside the collar prevent moisture getting in between the barrel and jacket. The number 86 tool is placed in the muzzle, and the barrel is tapped to the rear. Number 1, you must never take out your loose barrel when dust or sand is going about, or in a damp atmosphere, as the outside bearing surface of the barrel and the inside of the jacket must be kept scrupulously clean and free from moisture. The new barrel is 9C. Here it is half into the jacket. It's important that the outside of the barrel is lightly covered with oil, T70, and it must not be touched with the hands. On no count must grease be allowed on the barrel or in the jacket, as it would fill up the clearance between the two and prevent proper seating of the barrel. Tool number 85 this time is placed in the chamber end, and the barrel finally tapped home. Graphite grease is smeared on the threads of the jacket. This stops them from rusting, so don't spare the grease. Incidentally, when you take out your loose barrel for 3 monthly cleaning all the old graphite grease must be wiped off, and the thread is cleaned with paraffin if necessary. Graphite grease is also applied to the sealing collar. This will prevent moisture getting in and rusting the threads on the front end of the jacket. Remember, the grease only goes on the thread and not on the Faraday ring. The breech ring and sealing collar are now replaced. The securing screw of the breech ring is tightened, and graphite grease smeared around the front of the breech ring. This will prevent moisture from getting in between the breech ring and jacket. Finally, the breech mechanism has to be assembled. We'll learn all about the working of it later. The only remaining part of the equipment is the shield, which is now being placed in position. It's bolted to the front end of the trail. It provides protection for the gun detachment. The flap can be lowered for traveling. At the left side there is a port, which can be opened for direct laying against tanks. Now we're going to describe the breech mechanism of the 25 Panda and show you how it works. It's of the vertical sliding block type. This means that the breech end of the gun is closed by rectangular block, which moves up and down in guides in the breech ring. The block is operated by this lever on the right side of the breech ring. It's known as the lever breech mechanism, or LBM. The LBM is key to a horizontal shaft, which passes through the breech ring key. To this shaft also there's a crank. This has two rollers at its outer end. These rollers travel in an inclined groove in the block. You will see it better in this diagram. As the shaft is rotated by the LBM, the breech opens and closes. To limit and cushion the downward movement of the block, we have this spring and plunger, known as the breech block buffer. As the block moves down to the open position, the toe on the LBM comes into contact with the buffer and prevents any further downward movement. Now let's close the breech again. But on the diagram, this time in the closed position, we must prevent it from being opened accidentally. The block is now in the fully closed position, but the crank is not fully home. During the last movement of the crank, the rollers come out of contact with the path in the block, and the flat on the crank just behind the rollers comes into contact. The crank, in this way, acts with a strut and supports the block in the closed position. The movement of the LBM is limited by the buffer casing. It's also limited by the crank coming up against the face on the breech ring. When the LBM reaches the curve's position, the catch on the handle engages with a stud on the side of the breech ring. This prevents any movement of the LBM, unless the catch is released by hand. Let's see how the empty cartridge case is extracted once the gun has fired. For this, we have extractors. These pivot loosely on the actuating shaft, run on either side of the breech opening. They're operated by the breech block. During its opening movement, Watch this happening on a simple diagram. The shaped surface on the front of the block forces the toe of the extractor forward. Now look again. As the breech block comes to the fully open position, the lips of the extractors lever the cartridge case from the chamber and throw it clear of the gun. Another job of the extractors is to hold the block in the loading position. The breech block buffer, which we showed you before, not only cushions the fall of the block, but crosses it upwards like this. Watch this happening on the diagram. The spring forces the block upwards until the hooks on the extractors engage with the projections on the front surface of the block. This holds the block in the loading position. When a fresh round is loaded, the rim of the cartridge case push and frees them from the projections on the block. The buffer spring now forces the block up slightly. In this way, the block partly covers the cartridge case and prevents it from falling out of the chamber. Now let's see all this in slow motion. On the gun, the breech is open. The block rises to the loading position. A fresh cartridge is loaded, and the block rises to the marking position. The rest of the closing motion is done by hand. We'll deal now with the firing mechanism. Don't forget to try all your spare breech and firing mechanism parts to see if they fit and work correctly. This mechanism is of the percussion type, the main part being a striker and mainspring. First of all, there must be some means of cocking the striker. This is done automatically when the breech is open. Watch how this is done in detail. The breech is closed again as the crank rotates. The striker is cocked by the train of cocking lever. Look once again. The striker compresses its spring in its rearward movement. The striker is now out. But we must stop it from moving forward. When the breech is closed, let's look at the mechanism from above to see how this is done. When the striker is fully cocked, a gear is forced from right to left by a spring. This prevents the striker moving forward once again, and you'll see that even without its spring, the gear is made to work by the inclined surfaces of the cocking sleeve and gear. To fire the gun, the firing lever on the left side of the cradle must be put by means of intermediate gearing. The gear will this time be pushed from left to right. The firing lever is pulled. There must be some means of cocking the striker. The striker is freed and travelled forward. Under the action of its springs, the firing pin at the front end of the striker protrudes through a hole in the block and fires the cartridge. Should the gun misfire, the striker can be recocked by hand and another attempt made to fire. Now we must look into the question of safety. This means that we must not be able to fire the gun if the breech is not fully closed. We get safety in 3 ways. Firstly, the control lever of the firing train is not opposite the recess in the breech block and can't move till the block is closed. Secondly, the forward movement of the striker is powered by the train of cocking levers until the crank is in the fully home position. Lastly, the striker is not in line with the cap of the primer until the breech is fully closed. Apart from these safety arrangements, there's a safety cap. If the gun is loaded and the striker cocked, it can be set to safe. This locks the gear to the striker case. It's important that at the moment of firing, the firing pin should have the right amount of protrusion. beyond the face of the breech block. If it hasn't, misfire may occur. The number 1 is responsible for seeing that. The preclusion test is carried out before firing. The buffer is removed, and the breech block lowered out of the breech ring. This will cock the striker. The striker is now released, its forward movement being restrained by holding the cocking handle. The number 16 protrusion gauge is used for checking the protruding firing pin. The minimum should foul and the maximum should clear. If the firing pin doesn't pass the test, it should be changed. Now let's look at the gun and see how all the component parts we've described for you function in action.
Guns, commence firing!
So there you have it, an original 25-pounder gun breakdown from a bygone era. When now I consider taking on panzers over open sights, as opposed to changing the gun barrel in some pitiless desert, I think I'd rather encounter the panzer. What do you think?